Hello and welcome back to 4.9 lesson part 2. Trying to see if my pencil is showing up today. It's not bad. Alright. Sine of A. So you were supposed to finish this yesterday. Sine is the opposite of the hypotenuse, the cosine is the adjacent over hypotenuse, and the TOA is the tangent, is the opposite over adjacent. We have sine from the angle A. Sine is opposite over hypotenuse, opposite, hypotenuse, cosine A, adjacent over hypotenuse, tangent A, opposite over adjacent, 6 over 8. Now let's switch corners. Sine B. From B's perspective, this is the opposite, and the hypotenuse is still the hypotenuse, so 8 over 10. And from B's perspective, this is the adjacent, 6 over 10, for cosine, which is adjacent over hypotenuse. And tangent, opposite over adjacent, 8 over 6. Now let's see what happened here. Just making these more visible. Okay, so the sine of A, 6 over 10, well, that's the cosine of B, 6 over 10. How is that possible? Well, from A's perspective, the sine is the opposite over hypotenuse, but from B's perspective, the cosine is this side, which is adjacent to B over the hypotenuse. So if you switch corners and switch from sine to cosine, it's the same ratio, because it's referring to the same side, because you've changed ends, and you've changed, instead of going across, you're going next to, and so that's the 6. Same logic for cosine of A. It matches up with sine of B. And then that brings us to tangent, the most interesting one, which is opposite over adjacent. But when you switch corners from A to B, you're switching the opposite and the adjacent. And so 6 over 8 flips to 8 over 6. Because from A's perspective, that's the opposite. 6 is the opposite, 6, and then it becomes 6 over 8. Tangent does. But from B's perspective, 8 is the opposite, so it's 8 over 6. 6 over 8, 8 over 6. Tangent flips over. Alright, so now we're going to look at this triangle. See if I can do this some cool way. Not the most cool printing lineup. Maybe 6th period has a better one. Sine of A from this. So this introduces you to a convention that the corners are capital A, B, and C, with the right angle always C, and then the sides are lowercase a, b, c, and this is kind of cool. The A side is the side that doesn't touch A. It's the opposite of A. C is the opposite of C, and B is the opposite of B. That's better than naming the A side after one of the sides that touches A, because then which side would you choose? So we always go across. And that actually goes not for just right triangles, but all triangles are named, the opposite sides are named after their opposite corners. Helps you keep track of things. Okay, that's not what we're learning today. We're learning about the sine ratio from A's perspective, which would be A over C. And let's just do the sine of B, B over C. Sine is opposite of hypotenuse. Cosine is adjacent of A, B over C. Hey, that sounds familiar. We just did that, right? Because we switched from B to A and switched from sine to cosine. Now back to cosine B, which is A over C. Tangent of A, A over B. Tangent of B, B over A. Use the information from the previous 2 problems to write the observations you notice about. We noticed it already. and tan A is reciprocal. Reciprocal. That means flip it over. Reciprocate. Do you think these observations will always hold? Yes. Logic. Yeah, because we base these not on observation, but on the understanding that when you switch from A to B, you're switching the opposite and adjacent, but when you switch from sine to cosine, you switch the side you care about, which means that these are the same thing. These are referring to the same side. The sine of A refers to the same, well, I should say the opposite. The opposite of A and the adjacent to B are the same side. Whatever is adjacent to B is opposite of A. So sine uses, whatever's opposite of A and was adjacent to B, that is the same side. So sine refers to opposite over hypotenuse. Cosine is adjacent over hypotenuse. But the adjacent to B is the same as the opposite of A. So, okay, that's the logic. That's the logic piece. Let's look at the conjectures. Is cosine A equal to sine of A? No. Unless it's a 45, 45, 90. Because in a 45, 45, 90, the opposite and adjacent are the same length. And by 45, 45, 90, I mean a right triangle with two 45 degrees. And then, then sine and cosine are the same because A and B are the same length. So the ratios are the same number. Even though you're building them with different sides, those two sides are the same length in a 45, 45, 90. Okay, this is interesting. So tangent, we're going to use our little code here. Tan A. Oops. Too far. All right. Tan A is A over B. Tan B is B over A. Oh, sorry, I guess I need cosine. Cosine is, or sine is A over C. B over C. Yeah, this is going to work. Literally, this is Is this true? Yeah, I think they're just reviewing tricky, cool things about fractions, because A over C divided by B over C is the same as A over C multiplied by C over B, right? When you switch from division to multiplication, you flip the second fraction over, and then these simplify to ones, and you get A over B. And look, that's where we started. So cool. Sine A equals cosine of 90 minus A. What is that about? Well, this is looking at the triangle. A is some degrees. Let's say it's a 30 degrees. Then that would mean that cosine of 90 minus 30 is, because remember, A is 30. I just said so, that's right. A is 30, so 90 minus 30 is 60. This is, so this is B, because it's not the 90 degree angle. The reason why this 90 is here is after you take out the 90 degree angle of a triangle, there's only 90 more left because the triangle has 180. So So basically, taking out the 90, so there's only 90 left. Taking out a, which gives us b. This is b. 90 minus a is b. So does the sine of a equals the cosine of b? Yeah, that's what we learned earlier. The sine of a equals the cosine of b. So yeah, this is a cool, tricky way of using. This is a cool, tricky way of using triangle equal 180 degrees. I'm not on the screen. Embarrassing. Triangles have 180 degrees. Use that to make trig truth. Cool. Thanks, triangles. What else we got? Cosine A equals sine B. Yes, that's what we learned. Cosine B equals sine of 90 minus A. No, because 90 minus A is B, and the cosine of B doesn't equal the sine of B. No. Unless 45. Okay, this is an interesting thing you should learn about. Putting 1 over something flips it over. Let's look at why. So 1 over tan B, which tan B with B over A. And tan A is A over B, just so we have a reference. We're going to see if we can make this turn into that, which we can. Let me see if I remember how. Oh yeah, we make this 1 into a 1 over 1, because that equals 1. So it still says 1 divided by B over A. But now we can say 1 over 1 divided by B over A. But then we know when you're dividing fractions, you flip this one over, A over B. Then you multiply. 1 over A is A, 1 times A is A, 1 times B is B. And now look at that, it says that. So putting 1 over something flips it over. So if you have 1, you divide by something, you're going to flip that something over. This is kind of interesting, and this will come back in pre-calc, maybe algebra 2. The following convention: if you take the sine of some angle A and then square it, people don't like writing all those brackets, so they just say sine squared of A. Like, it kind of makes sense if you think about it. I hated this at first, but now I like it, because basically what you're saying is the sine that you're going to get, square it, and then what are you going to get it from? A. So this kind of breaks notation, but it's what we all use. So this actually means find the sine first, then square it, even though it looks like it says square the sine, then find it from A, which is what it says here. Take the sine of A, then square it. But that's what this means by tradition. So if you take the sine of A and square it, and then you add the cosine of A and square it, will that equal 1? What are they even talking about? Well, let's try an example. Six over 10, 8 over 10. So 6 over 10, that was squared, plus 8 over 10 squared equals 1. Whoa. Now this is based on Pythagoras, because look, it's kind of like a squared plus b squared equals c squared. However, we're not taking just the sides, we're taking the ratios of the sides. And so when you take the ratios of the sides, they fit more like a puzzle. You still got to square them, though, to make the Pythagorean part work. And so it's actually more like this. Side A over the hypotenuse squared, that's the A squared, plus side B over the hypotenuse squared equals side C over the hypotenuse squared. We're comparing everything to the hypotenuse. Everything in the Pythagorean theorem is getting divided by 10, which is allowed because you're allowed to divide both sides by 10 of an algebra equation. But then a weird thing happens. What's 10 divided by 10? 1. What's 1 squared? 1. But then it works out because the other two ratios, when they get squared, add up to 1. Thanks, Pythagoras. One minus sine squared of A equals cosine squared of A. Isn't this just a rearranged version of the last one? Because if you add sine squared of A, you get 1 equals sine squared of A plus cosine squared of A. So if you're wondering like what is going on, we're just looking at some algebraic implications of these cool ratios that we found. Sine squared of A equals sine of A squared? No. There's probably one exception where this works, but basically sine squared of A says find the ratio, square it. This says take the degrees and square it. What if it's 50 degrees? So what's I'm going to use this 50. Look, sine of 50 degrees is 0.77. So this says to find the ratio, 0.77, then square it. Is that equal to the sine of 50 degrees squared, which would be 2,500? No. Where's my phone? Well, first of all, this doesn't even make sense to us, because how can you have 2,500 degrees inside of a triangle? You can't. But in pre-calculus, you'll develop a system where you're allowed to go past what is possible in a triangle. And it makes sense. It's kind of cool. It's kind of the coolest part of trigonometry. But it all starts with triangles. But if you did, this would equal negative 0.34. Pretty cool. It just means that the orientation of the triangle is flipped around. So now we have a negative ratio value. But obviously, this does not equal whatever 0.77 squared is. I have to look that up one sec. 0.5929 does not equal negative 1.34. Is that it? We done. I thought there was one more page, but I lost it. Let's just stop there. Nah, that was a joke. I think that was the important stuff. Wait. Nope. I'm gonna look for it.